book discussion, Something Deeply Hidden, Sean Carroll. This is the second installment of today. I want to discuss a couple of ideas from the book. I'm also going to explain why I'm coming, because I read this book a while ago, and I think it's relevant intellectually, but also applicable to our operation in the financial markets. This is the Not Even Wrong podcast. It's February 10th, 2021. This is Krim Delko. Since the last update today, we're down another 1.5%. For the year now, we're up 19.5%. The market's up 4%. We're outperforming by 15.5%. I want to discuss Something Deeply Hidden by Sean Carroll. I've read the book probably a year ago, and I just came across recently because there's one fundamental idea in this book that really made me think recently why it's a very important idea. Here's the idea. So there's the problem in quantum physics is that we understand roughly what's going on in quantum physics from an observational perspective, meaning we can use the theory to make predictions, but we don't really understand the underlying theory. And Something Deeply Hidden is a try by Sean Carroll to reverse that, basically to say we can derive what we see, we can derive reality from the theory. We can stick with the wave function, with Schrodinger's wave function and quantum theory as we understand it. And if we just in an orthodox way, stick with the theory and have explanations that are consistent with the theory, we can actually explain what we see. And one derivation from this thesis is that the multiverse theory applies, meaning that if we really stick with the concept of a quantum system that is splitting at any point in the quantum space, so whenever a particle is exposed to what we now call decoherence, the world splits and the wave continues, meaning there is one large wave function that is physics, reality, and the splitting is within that wave function. We split the worlds. Now, look, I'm not qualified to explain this in words in a podcast here, so I'm not even going to try. But what I think I can derive from this attempt by Sean Carroll is the desire to explain reality from a theoretical point of view, instead of trying to fit theory into the reality. For example, by having something called hidden variables, where we're saying, okay, there's a theory, it doesn't match reality, so let's add some variables to it, or even the more extreme case of that, the Niels Bohr interpretation of quantum mechanics, where they kind of said, well, if we observe something, then the wave function collapses, otherwise it doesn't collapse. This is not satisfactory. So what Sean Carroll is trying to do, he's trying to derive from fundamentals, from first principles. He's deriving theories and other known theories, for example, also space-time. Here's an example of what he's saying. So there's two fundamental concepts within quantum mechanics. One is the wave function, the other is entanglement. And space is simply defined by entanglement. If things are entangled, the more entangled they are, the closer they are together, the less entangled, the further. And you can also derive the curvature of space-time and gravity from the wave function. According to Sean Carroll, we're not there yet in terms of actually mathematically and definitely not experimentally proving this, but it is, I think, a thought experiment which is very useful. And this leads me now to the actual reason why I think this book is so important. And you might see a pattern here. One of the 4 books that underlie our principal stack is David Deutsch's The Beginning of Infinity. So we are definitely influenced by theoretical physics and epistemology that derives from physics. But what it really comes down to is the first principles approach. And this is, of course, something that Elon Musk has been talking about a lot. And what first principles approach means, and I would say first principles is even the wrong name. I would just call it base principles, because we are not really sure what's first. But let's assume that the theory of quantum mechanics and the Schrodinger equation and the wave function are the beginning. This is what physics is. This is what the underlying mechanics of reality are described in the wave function, in the Schrodinger wave function, and we can derive everything we experience from there. And we have to find explanatory theories that explain what we see. So, for example, how come that if there is something like space-time, how do we explain that from the theory of Schrodinger's wave function? We include entanglement into the explanation, and we explain that space and curvature are derived from entanglement. How do we explain the superposition of things? Well, the splitting of the universe, or the splitting of the world. So we are a quantum system. We, meaning humans, are a quantum system because within our own bodies there is a constant splitting of universes, and we observe things that are quantum systems because everything is quantum. And this goes back to something that I picked up from Charles Bennett at a quantum cryptography conference that I attended, I think about 3 years ago now. He was present there. He's one of the fathers of quantum cryptography, and he said that every computation is quantum. It's just that we do shortcuts and call it classical computing. So we humans, in order to simplify our explanatory powers, use emergent factors. That's a very common thing in physics, which means that we have less information about an event, but it describes something that is relevant to us, even though we don't clearly understand the underlying factors. Reality, curvature of space-time, space, time, all these concepts are emergent explanations for what we see in reality that makes it easier for us to function. And emergent factors, emergent explanations are a very common thing in physics. In fact, they are even explainable through evolution, because it just, it makes it easier for us to, instead of going back to the basics of quantum mechanics to explain something like time, we just have this thing called time and we call it time. But it really emerges from the Schrodinger wave function and from entanglement, that these things, that we perceive these things, such as time and gravity. So Sean Carroll is very vocal about the fact that he's not there yet with the theory. So it's not like he can, there's a paper with equations and things like that which can prove that. The book is more of a groundwork, and he said that recently in an interview. He said, I hope my book will have a more influence in 20 years when the first generation of grad students maybe goes to get PhDs and professorships that have grown up with my book. So he's probably thinking more that the current physics profession is probably too biased and will not pick up on his book, but maybe the people now in high school are reading his book, they're going to go to undergrad and grad and school and so on and so forth, and that people will work on building theories out of the quantum mechanical building blocks and not try to fit reality and match it with theoretical concepts that are not part of the fundamental first principles. So again, this is something that we believe is very, very important for us also at Orange Capital Partners. It kind of relates to the episode about the principles. I think it was yesterday when I said that principles are most important when they're easy to ignore. Now, I wouldn't argue that we at Orange Capital Partners use first principles, by no means. It's not like we're going back to quantum mechanics to derive investment ideas. We have a principle stack. The principle stack is based on 4 books: The Beginning of Infinity by David Deutsch, 0 to 1 Peter Thiel, The Innovation Stack, Jim McKelvey, and The Innovator's Dilemma, Clay Christensen. These are the building blocks of our principle stack. We derive our actions from that principle stack. And like I said, it is very easy to ignore that principle stack sometimes, but that's when it's most important. So we didn't invest in Bitcoin, even though we had good indication that there's money to be made, particularly when Square started buying, and then later on when Elon Musk started tweeting, etc. We didn't do it. There are other, for example, situations where you could have, I don't know, you could have thought maybe DoorDash is a good investment, at least short term, because we have COVID and all that. It's a bad business. It doesn't apply to a principal stack. Uber is the same way. There's a lot of businesses out there, a lot of stocks actually, that that don't fit our principal stack. That they might be money making, and we're not gonna ignore our principal stack just because it's easy to make money. I think in the long term it will serve us well. So in that sense, we see ourselves in that school of thought of Sean Carroll, which is stick to the theory, stick to the fundamentals, the first principles, and derive your reality from that theory. And that's how you're going to succeed intellectually, and in our case also in terms of generating wealth. Thank you.